What is the sum of both values of x which satisfy square root of x squared is equal to the square root of 2005 squared? Well, let's work with this here. So if we take the square of both sides, then we'll have, I guess, this left. And then if you take the square root, we'll have x is equal to plus or minus 2005. So the first root is 2005, and the second root is minus 2005. And they want the sum of these, so if you add this plus this, obviously the sum is 0. What is the only ordered pair of positive integers for which x squared minus y squared is 7? All right, let's factor that. I think factors pretty easily. X minus y, x plus y is 7. And then, well, this guy here could be a 7 and this could be a 1. That's one way of doing it. I think that's the only way of doing it since 7 is a prime. So if that's the case, x plus y is 7. X minus y is 1. And then we can work with these two equations. If you add these two equations, you'll get 2x is equal to 8, and therefore x is equal to 4. Substitute that back into any one of these, and you'll get y is equal to 3. So our ordered pair xy is 4, 3. And of course, you can plug it back into here to verify that that solution indeed does work. Two shaded squares are drawn inside a rectangle as shown. If each square has an area of 64, what is the area of the rectangle? All right. Well, since they already have the diagram, I won't bother drawing it again. I'll just enlarge it a bit. So they're saying the area is 64, okay? The area of what? Oh, each square, okay. So if the area is 64, then that means the sides are 8, like that. Yeah. And then, because of the symmetry of this diagram, I'm going to label this x, and then therefore that's going to be x also. And that's also x. And if you were to cut this in half like that, this is x, and that's x. Okay, so the area of the entire thing would be 2x times 4x, which is 8x squared. Now, of course, we have to figure out what x is. Let's just concentrate on this triangle right up there. And that triangle, since that's a right angle, that would give us the Pythagorean relationship of x squared plus x squared is 8 squared. So that's 2x squared is 8 squared. So that's 2x squared is 64. And therefore x squared is 32. And therefore this would be 8 times x squared, which is 32. And that is 256. Al and Pat each take coins from a piggy bank to buy some gum, but Al is 10 cents short and Pat is 15 cents short of the price of the gum. If they combine their resources, they still can't afford to buy the gum. What is the greatest possible integral price of the gum in cents? All right, so Al and Pat. Okay, so the gum price, let's see here. He's 10 cents short just with his money. So I don't know what the price of the gum is. I guess that's what we're trying to figure out. But he's 10 cents short, so that would be 0.01. Yeah. And then Pat, if the price of the gum again is G, is 15 cents short. And when they add these two, that would be 2G minus 0.25. This is also apparently less than the price of the gum. Okay, so now we have to figure out what G could be. So G is less than 0.25. So the greatest possible value would be 0.24. So 24 cents. Yeah. So I'd like to see what kind of scenario I could get here. Let's say Al had 14 cents and Pat had 9 cents. So is Al 10 cents short of the 24? Yes, exactly 10 cents short. Is Pat 15 cents short? Yes. And when you combine them, it becomes 0.23, and that is also less than the 24 cents. So it all works out. What are all the real values of x which satisfy this equation? All right, so if I were to let x squared plus 2x plus 1 equal to 1, then this equation, this whole thing, becomes 1 over 1 plus 1 plus 1 plus 1 over 1 plus 2. And that is actually 1 over 2 plus 2 over 3, and that does indeed equal 7 over 6. So it all works out. So we're really making a quick substitution like that. We modify the problem into something very simple. This, of course, just as x squared plus 2x is equal to 0. And if you factor out the x, you get x plus 2 is 0. And therefore x is equal to either 0 or negative 2. And that is actually the answer. For all x polynomials f, g, and h satisfy the following equations, what is the least possible value of f10? All right. I'll call this equation 1, I'll call this equation 2, and I'll call this equation 3, and let's see what we can do. All right. Well, let's start with equation 1, I guess. If the absolute value of f at x is equal plus g at x is equal to 4x, that could mean one of two things. It either means that f at x plus g at x is equal to 4x, or it means minus f at x plus g at x is equal to 4x. It all depends on what is the value of f at x. It's greater than 0 or less than 0. And then similarly with equation number 2, if the absolute value of f at x plus g at x is equal to minus 2x squared, then again that means either f at x plus g at x is equal to minus 2x squared, or it means that minus f at x plus g at x is equal to minus 2x squared. Okay, so what do we do now? We can add. Let me just add. What should I add here? I'll add this one. I'm just trying to think here. This one and this one. If I add those two, oh sorry, wait. Let me think about this for a second before. I'll add this one to this one here. I think that's what I meant to say. Okay, so if I add those two, I will get 2g at x. I just got to do this carefully here. 2g at x. The f at x is cancel, right? Because one's negative, one's positive. And then on the other side, we just get 4x minus 2x squared. Okay, divide through by 2, we get g at x is equal to 2x minus x squared. Okay. And all right, so then what? Then I think at this point, since we have this is actually fairly helpful, I think, because then we'll call this 4, and what we'll do is we'll sub that 4 into the 1, this one up here, that one up there. Yeah. Yeah, because we want the least possible value. Yeah, so probably best to go with the least possible values of x, which is x less than minus 2. Okay, let's do that. So we got f at x, absolute value, plus g at x. But g at x is 2x minus x squared is equal to 4x. Okay. And then that means that f at x absolute value is equal to, put everything on one side, and that'll be 2x plus x squared. And therefore that means that f at x is either 2x plus x squared or minus 2x plus x squared. Okay, so therefore, what are we trying to figure out again? Oh, f at 10. So f at 10, if we put it in here, this guy, that would be 2 times 10 plus 10 squared, which is 120. Or if you put it in here, it would be minus 120. And what do they want? They want the least value. Well, the least of these is this guy, minus 120.